Hello and welcome to the CTO Show with Mehmet. My name is Mehmet, and in each episode, I will be exploring the latest trends, insights, and strategies in topics like cybersecurity, digital transformation, emerging tech, startups, and entrepreneurship. From thought leaders and innovators to entrepreneurs and founders, we will hear from experts across a wide range of industries who are driving change and making an impact in the world of tech and business. Thank you for tuning in. Let's get started. In this episode, I will be exploring edge computing, a distributed computing paradigm that is revolutionizing the way we process and analyze data. Edge computing is a technology that brings computation and data storage closer to the location where it is needed to improve response time and save bandwidth. With edge computing, data processing happens at the edge, which is closer to the source of the data, reducing the time it takes for data to travel back and forth from the cloud or the data center. This technology is different from cloud computing, which involves centralizing computing and data storage in remote data centers. Edge computing brings computing closer to the end users or edge devices, which could be sensors, cameras, or smartphones. What are the benefits of edge computing? The benefits of edge computing are many, including reduced latency, improved reliability, and increased security. Since the processing happens at the edge, data doesn't have to travel back and forth to the central location, whether it's a data center or the cloud, resulting in a lower latency and faster response times. This is very important for time-critical applications like self-driving cars or industrial automation. Edge computing also improves reliability since it can continue to work even when there's no network connectivity, unlike a cloud computing perspective, which needs a continuous connection. Edge computing also improves security since it limits the amount of data that needs to be transmitted over the network, reducing the attack surface. Let's have a look on the edge computing architecture. The architecture of an edge computing system consists of edge devices, gateways, and cloud infrastructure. Edge devices like sensors, cameras, or smartphones collect data and send it to the gateway for processing. The gateway is responsible for aggregating data from multiple edge devices, processing it, and sending it to the cloud for storage or further analysis. The cloud infrastructure can be public, private, or hybrid, depending on the use case. In edge computing, data is processed and analyzed at the edge, which reduces the load on the cloud and improves the response time. Let's have a look on the challenges and limitations of edge computing. While edge computing offers many benefits, it also poses several challenges and limitations. One of the main challenges is network connectivity, which could be limited or intermittent in some areas. This could affect the performance of the edge system, especially if it relies on real-time data. Another challenge is data privacy, which is a concern since the data is collected and processed at the edge. Data heterogeneity is also a limitation since edge devices come in different shapes, sizes, and configurations, which could make it challenging to develop a unified edge computing systems. Now let's have a look on the use cases of edge computing. Edge computing has many use cases across different industries. For example, in the healthcare industry, edge computing can help process data from medical devices in real time, reducing the need for patient data to be sent to the cloud. In the transportation industry, edge computing can help power autonomous vehicles by enabling real-time data analysis, reducing the need for data to be sent back to the cloud. In retail industry, edge computing can help improve customer experience by enabling real-time analysis for customer data, allowing for personalized recommendations. What is the future of this technology? The future of edge computing is exciting with many new applications and services being developed. With the advent of 5G networks, and now we are talking about 6G networks, edge computing could become more ubiquitous, allowing for new use cases like AR, VR, autonomous vehicles, and telemedicine. The development of new technologies like artificial intelligence and machine learning could also improve the capabilities of edge computing. And actually, we have seen some implementations on these very small devices where machine learning can be applied at the edge. This can help in making it more efficient and scalable. Edge computing can also help businesses save costs by reducing the amount of data that needs to be transmitted to the cloud, thus lowering bandwidth and storage costs. Implementing edge computing in business can be a complex process that involves several stakeholders, including the IT department, operations, and different business units. To implement edge computing, a business needs to identify use cases where this technology can add value and then evaluate the technical requirements such as the hardware, software, and connectivity. A business also needs to consider the security and privacy implications of edge computing and develop the required policies and procedures that can ensure they are still in compliance with regulations and best practices. Finally, a business needs to train its employees and develop culture of innovation that encourages experimentation and learning. Let's have a look on a case study to understand a little bit more about the benefit of edge computing. And let's look at manufacturing. To understand how edge computing can be implemented in business, let's look at a case study from a manufacturing company that implemented edge computing. The company had a problem with downtime in its production line, which was causing delays and reducing productivity. By implementing edge computing, the company was able to analyze data from sensors in real time, predicting when equipment was likely to fail and preventing downtime. The company was also able to reduce the amount of data that needed to be sent to the central location, thus saving on bandwidth and storage costs. In conclusion, as you can see, edge computing is a technology that's changing the way we process and analyze the data. The benefits that we talked about, like reduced latency, reliability, increased security, make it an attractive option for many use cases across different industries. The future of edge computing looks promising, with many new applications and services, and that tied together with the new trends like artificial intelligence and machine learning, it is very obvious that it would be the next era of computing. Don't forget that always you need to start from a business case perspective, identify what are the current pains, and then moving forward, evaluate the technical requirements that you would need in order to solve this pain. Thank you very much for listening to this episode. I hope you found it useful. I tried to bring a new topic that I didn't cover much before. So as usual, if you have any feedback, if you have any comment about this episode and about the show in general, I would be more than happy to discuss it with you. You can reach out to me by email, LinkedIn, or Twitter. And until we meet next time, thank you very much for tuning in, and we'll meet in the next episode. Bye-bye.